Okay, in our previous video, we've made these sort of 3 reference copies of this original object. And we're going to look in more detail at these options. So mesh smooth is one of the oldest smoothing operations, and it's a quad division operation, as all these are. Okay, let's put it back on 2 iterations, or let's put all these back on 1 iteration and sort of try to figure out what quad division means. Okay, so we'll start with tessellate. I'm going to set the tension to 0 and make it more obvious what's going on. So each of these faces has been divided into 4. It's been divided into 4 by taking opposite edges and drawing a new edge across them. So this one flat face is now 4 flat faces. And we see it's done it on every side. Tessellate has this tension option that gives you this parameter that affects sort of, I guess, tension. It's almost like a suction or balloon value. Okay, and it can be pretty handy to make some sort of interesting shapes. This is right here. This is sort of an interesting, maybe start to a bench, and I could come in here and modify this further. Okay, we're going to leave this at 0 for now. There's also an operate on triangles versus operate on faces. We tend to think, I think, more smoothly in polygons, but sometimes triangles is useful. So that's tessellate. Okay, and I'm going to just push that one back a bit. And now we have mesh smooth and turbo smooth. For the mesh smooth operator, I'm going to turn off isoline display. And we see that these two look basically identical because the operations are effectively the same. And this is just like our tessellate option. It's divided each face by 4. But what it's done is each of the vertices has been averaged in space with its neighbors. So this has the effect of bringing high, far away vertices in. So we see the vertice that was here is now this vertice here. Okay, and I can turn on sub-object vertex here. And you can see that. You can see this is the original vertex, right? And it's been pulled in, sort of the new one has been pulled in there, okay? And turbo smooth works the same way, right? It sort of averages out the shape. So the far away points get closer in, the tight in points might get a little sort of pushed up towards another point. And overall, you're led to this smoother object. As you increase the number of iterations, the number of times that this is happening is increased. Each time is a 4-fold increase in the number of faces. So we see 12 faces here because this one is divided by into triangles already. This one has 24 faces right now. So it goes from 6 to 24. So 4 times. To 96, that's times 4, times 4, times 4, etc. Okay? For our purposes in class, we're never going to need more than 4. And if you go to too high of a number, you will crash the computer. It happens every year. So never really above 4. Okay? But 4 gives us this nice, beautiful, stone-looking smooth. Let's turn off edge faces for a second. We can even render this out. This nice smooth object, okay? And it could be a chair back or a pebble or it could be any one of a number of things, okay? So we're gonna leave it at 2 for now because 2 gives us an idea of how smooth it's gonna be, but doesn't cost the computer a lot of effort. I'll put this one at 2 also. So these are the same right now. Turbo smooth doesn't have a whole lot of options, okay? I'm going to put edge faces back on. Not a whole lot of options here, and that's usually good for our purposes. It makes it more obvious what's going on. Mesh smooth does have some fancy parameters. We're not really going to leverage them in the class, but I will show them to you here real quick. We can locally control which parts are smoothed. So I can select edge here, and it gives us this cage. And I can click on an edge, and I can do a couple of things. I can move this edge, okay? And this has the exact same effect as if I went back to the original object, selected edge with the 2 key, and moved the edge. We see that it looks identical to what was just happening. Okay. So maybe not really interesting, but it might be useful. What's more interesting is, let's select this top edge, this sort of blade edge at the top. And we got these crease and weight values. Okay. So what do? Well, they affect how strongly that averaging is occurring. Okay. And I can increase or decrease the weight. So, and in fact, increasing the weight, it sort of averages away from it more, and decreasing the crease averages away from it more. Okay. So they kind of, I guess the numbers kind of do opposite things, but we can get this really sharp edge. So if we select actually more than one edge, so let's select all 3 with the control key, all 3 of these back edges. Okay. And I'm going to set the crease to maximum. And I'm going to set the weight to about 1. And what we end up with is this really interesting shape here. Let's increase those iterations up to 4 again and turn this off. And what do we get? We get this sort of weird, I don't even know how to describe it. It looks like it could be a suction cup against a wall or something. Right? So this can give us some really interesting shapes with this really hard edge here and really nice smooth curves here. Definitely keep it in mind that this is available. It's not how we're going to do most of our modeling, but it is there if you need to do just that one thing. You want to retain that sharp edge on your building or your object that you're modeling. Okay. For our purposes, we're going to generally stick to Turbo Smooth. It's cleaner, it's more obvious what's going on. Okay. In the next set of videos, we're going to start modeling a broom from the Harry Wizard movies. Wizard Potter, can I say it? So we'll look into how to sort of create new geometry and apply these smoothing techniques to make really nice looking, clean looking models. Okay, thank you.